So for the next section itself, we're going to talk about practical electricity. Now, this is actually not the lab practical not the lab practical. This is like saying real world electricity. Okay, so in the real world electricity itself, we know that electrical power, so this is power, this is energy, and this is time. Okay, we're going to use your units. Now, do take note, these are not SI units. Okay, now there is a reason why we are not going to use your SI units itself, because when we use power, energy, and time itself, in this case, we actually use kilowatt hours for power. So for example, power itself, we can say 360 kilowatt hours, for example, just a number. Okay, sorry, I said wrong. This is energy. Okay, so for power, right, typically power is in watts. All right, so in this case, we're actually using kilowatts. So same thing as your meters and kilometers itself. If you want to change from watts to kilowatts, we divide by 1000. If you do the other way around, we times 1000. So your kilowatt hour over here, this set of units down here, it is actually just kilowatt times hour. So basically you can see this is actually your power times time. Energy is power times time. All right. Now, why we don't use joules, which is the SI unit for energy, right, is because joules itself, your number, if you actually go and calculate it for the amount of electricity that we use, is going to be super duper big. So for example, 450 kilowatt hours is going to be 1,620,000,000 joules itself. So can you just imagine your parents, if they open up your electric bill and then it says, see a few billions of energy that you use, you'll cry, right? So do take note about this. I'll just do a quick calculation at the side to show you what I mean by this. So 1 kilowatt hour, okay, let me just write down. Energy is power times time. So if I say 1 kilowatt hour, it's the same as 1 kilowatt times 1 hour. So ask yourself, 1 kilowatts, if I change it to watts, I just times 1000, right? And then for time, hours, I'll change it to seconds. I'll take 60 times 60, because 60 minutes, 60 seconds. So you end up with 3,600,000 joules. That is why we don't use SI units, because just 1 kilowatt hour is already 3 million something. So if you have the 450 here, you can end up with 1 billion something. So it's going to be a very, very crazy number. So it's very hard for us to actually calculate, especially when you have to calculate the cost of electricity. Like how much does your electricity cost every month or whatsoever. You can see every kilowatt hours only cost 20 cents. But if I need to use joules, you see the number of zeros. You look so many number of zeros, your eyes will go haywire, right? So because of that, we usually use kilowatt hours. So to break down, right, what does it mean by 1 kilowatt hours? 1 kilowatt hour is power times time. Okay. So if you ever see these kind of things, don't just repeat, oh, energy is blah, blah, blah. Okay, it's just the amount of energy converted by this amount of time. Okay, so SI unit by right, it should be joules. It's in watts and seconds. All right, this is watts, not weight. Do take note. So let's take a look on how we solve this kind of question. So number one, you have 12 100 watts. Okay, this is power of light bulbs. All right, and you use it for 6 hours. This is the time for the light bulb. Then you have 3 kilowatt kettle and you use 40 minutes. You want to find total cost. Okay, and they tell you the cost of electricity is 20 cents per kilowatt hours. All right, so for kilowatt hours, first thing is we need to first ask yourself, what's the power of my light bulbs? It's 12 times 100, right? Then you end up with 1200 watts. Now ask yourself, is this in as the correct units? No, right? We actually need to use kilowatts and hours. So we change it to 1.2 kilowatts. Then ask yourself, what's the time taken? It's already 6 hours. So don't need to do any special calculation for this. So you can ask yourself, what's the energy used by my light bulbs? It's 1.2 times 6. 7.2, and take note, it's kilowatt times hours, so kilowatt hours. Okay, then you ask yourself, for my kettle, how much did I use? 3 kilowatts. Okay, good. I don't need to do calculations. What about my time? Time is 40 minutes. So if time is 40 minutes itself, I use 40 over 60 hours, right? So because this is going to give me a fraction, I'm just going to leave it as it is. So ask yourself now, how much energy did I use for my kettle? So I use 3 times 40 over 60. You end up with 2 kilowatt hours. Okay, so your total energy you want to ask yourself is 7.2 plus 2. You end up with 9.2 kilowatt hours. Okay, so you end up with 9.2 kilowatt hours. So the next step is just to ask yourself, how much did it cost? So I'm just getting 9.2 times 22 cents. Now for 22 cents, we always put it in terms of dollar signs, because if you use cents, right, we don't know whether to use 2SF, 3SF, 2DP, how many, what's the value to round up, right? But if you use dollars, we always use 2 decimal places. Okay, so let me just press this, my calculator. You end up with 2.24, and we're going to round it up to 2, because for money, we always use 2 decimal places. So it's a bit special, right? So we don't use SF, we will use decimal places for money itself. So you can see over here that yes, this kind of question looks very simple, but there's actually a lot of things. You need to be very careful, because I know a lot of students, you all don't like to use the symbols. You don't like to write, you just like to straight away solve, right? Like maths. But the thing is, if you don't write all of this, how do you know which does this belong to? Because a lot of you also don't write your units. You all just write the numbers. So if you just put in the numbers, and there's so many values here, how are you going to figure out which is which? It's very, very easy to get careless mistake if you don't write the correct proper units itself. So do take note about all of this. Okay. Now, next part over here is your color of your wires. Now, if you notice all the wires around you, yes, we only see one single like black wire or white wire or whatsoever, right? But inside those tube of wires, you can see there's actually 3 wires inside them. And these 3 wires wrap around copper wires, all right? So first things first is you can just see that your high potential terminal is what we call your positive terminal, and your low potential terminal is what we call your negative terminal. So you can just treat it as if it's a battery, all right? So what we mean by this is your high potential terminals are what we call your live terminals. These are your dangerous ones, okay? So your live wires, basically wires that are connected are called your live wire itself. So live wire, okay? Then your neutral wire itself is for the low potential wires. Now, they are still going to be dangerous. Okay, both of them are still dangerous. But the thing is, neutral wires are less dangerous of some sorts. Basically, your live wire is the most dangerous one. All right. Then your, okay, so not neutral terminal, it's called your neutral wires. Neutral wires. Okay. Then your earth wire itself is a bit special. It's a safety feature. Okay. So basically, we have your brown, neutral, and your earth. So how do you remember which color is which? For me, life itself is basically if you touch, you get shock. You become brown. Because if you look at those cartoons, for me, it's Pokemon, the first episode itself, where Ash touched Pikachu, Pikachu shocks him, he became brown in color. So for me, that is what I remember it. So always try to come up with your own way to remember it yourself. For me, it's, oh, if I touch it, I just imagine like a cartoon of me getting shocked, and then I become brown color and charred. Okay. Number 2, neutral. When you think of neutral, you think of very chill, very cool, right? You think of very chill and cool. What happens is, what color is chill and cool? Then you close your eyes, you think of chill and cool. The first thing you think of is going to be blue color, because blue is a very, very relaxing color, look like water, look like waves, very chill, very relaxed. That's what I remember. All right. Then for earth itself, you think of nature, right? And when you think of nature, you think of the land, you think of the trees. So trees is green, your land is yellow. So together, you end up with yellow and green. So the thing is, we don't just write green, we don't just write yellow, we must have both yellow and green, green and yellow. So this is how you remember which color is which. Just remember, brown is the most dangerous, blue is also dangerous, green and yellow is supposed to protect you from these two dangerous ones. Okay, so now if you look at the back of your 3-pin plug itself, you notice if you open it up, this is what it looks like from the back. So in front, you will notice that there's probably the pins are somewhere in front. Okay, so you can see that there are pins somewhere in front. Okay, you can't really see it, but basically they are in front. Okay, so your live wire is always the one on the right hand side attached to this thing on the over here. This part, it will be attached to what we call a fuse. Is actually another safety feature. So you cannot see it. This is a fuse. Okay, this thing over here is a fuse. Okay, then your neutral wire will be on the other side, and then your earth wire will be the one on top. Okay, so one important thing that a lot of people will forget is this thing over here, your cable grip. Your cable grip should always be above your outer insulation. This is to prevent short circuit. Because don't forget that your parts over here, the cable grip could be made of metal, could be made of plastic. The wires, if they were to accidentally touch the other two, what happens is that you can actually cause a short circuit, and short circuits are dangerous because you can produce a lot of heat and you could actually damage your environment. You could also cause a lot of troubles. We'll learn more about the troubles later, but do take note, your cable grip must always be above your wires, because how some of the questions are phrased is they'll give you a diagram, then they'll ask you what is wrong with this setup. Then you need to be able to answer them what is what. Just need to take note of the positions itself. Your live wire is always attached to some additional parts. Your earth wire is always on top. Your neutral is like this. So if you were to look at 2-pin plugs don't have the top wire, which means they don't actually have earth wire. They have other safety features to protect them. All right, so do take note about this. All right, you can see over here, all wires are wires, which means they're all dangerous. So if you were to connect your blue wire to the live wire, they can behave like a live wire. So which means if you connect it wrongly, they will still behave as it is, just that the configuration itself is kind of wrong. So you just need to be careful which wire corresponds to which wire. Because ultimately, all of them are wires. They all can conduct electricity. So if you would touch them with your bare hands, yeah, good luck. Okay, don't do that. It's very, very dangerous. You will die. Okay, so do take note about all of this. High potential, low potential, low potential, all of this, the colors to and fro. So you can just imagine if you have a normal circuit, light bulb, for example. So what happens is this is your live wire. This is your neutral wire. You can see that your current is actually flowing in this direction. So which means if you touch your live or your neutral wire, you will get zapped. So now the question is, so if my live is here, my neutral is here, where's my earth wire? Your earth wire is actually connected to your metal case. Okay, it is connected to the metal case. So it's not actually inside the device, because for your light bulb itself, it goes in and it comes out, right? But for your earth wire, it actually is only at the metal case of your device. So it's actually protecting you from the dangerous parts. Because normally, what do we touch? If we touch for example, a spoiled light bulb, if we touch the metal case, we will get shocked. But with the earth wire, we won't get shocked. Okay. So you can see in this setup over here, you can just imagine this is your live wire itself. Oh, by the way, if you don't remember, this is your fuse, the thing on top. This thing here is a fuse. Okay. So your live wire goes in. What happens? It goes in, it comes out. So basically, you can see it flows like that, right? Now, this is assuming everything is normal. However, if things are not normal, what happens is maybe there's a problem over here. Okay, which means you are now spoiled. Okay, the wires now touch the metal parts of my metal casing. Which means if I were to touch it, this is my finger. Okay, so if you were to touch it, current will flow through and zap you. you will die. Okay, so to avoid that, we have what we call your earth wire. Okay, so if you have an earth wire itself, what happens is current will be forced to flow through here. Why? Because your earth wire has 0 ohms. It will actually cause short circuit. So if it short circuit, no current will flow through. And if no current flows through, you do not get shocked. By the way, how come humans can get shocked? Because we are non-metals, right? How come we can still get shocked? Don't forget, humans are made of 70% water, which means water can conduct electricity, which means 70% of us can conduct electricity. So it will actually flow through your blood, shock you. And don't forget, when current flows through anything, it will cause a heating effect. So it actually burn you and heat up your blood. It basically cause a lot of damage to your bodies, damage your nerves. You'll be not sure whether you're lucky or unlucky enough to survive if you touch electricity. So please don't do that. It's extremely, extremely dangerous. Leave that to the movies, okay? Don't do it yourself. It's very dangerous. Leave that to the professionals or to the electricians and all that. They know what to do. They know how to handle all your electricity properly. So please be careful about it, right? Do be careful. Next part. So for your hazards itself, electricity is very, very dangerous, right? So why are we still using it itself? Your hazards can be separate into electric shock, electric fire. Okay, so number one, what causes electric shock? Basically, current flow through person. So if and only if the current flows through you or anybody that's touching the wires itself, that's what we call an electric shock. Now, what about electrical fire? This is when you have high current in wires or device. Okay, so if and only if you have very, very high current, so don't forget, when you have a lot of current, what happens? You will heat up very fast, right? And if you heat up very fast, what happens is that your wires might actually catch fire. So if your wires catch fire, the scary thing is some wires are inside the wall. You might not be able to detect it or stop the fire before it's too late, which means that you could technically burn down your house if you have very, very high current in your wires. So please be very, very careful about this. These two are your main hazards of electricity. It's very dangerous, right? So you can see over here, electric shock is when you touch. Over here, what happens? Current will flow through, you have an electric shock. Okay, you see this high potential part is asking you when you are basically you touch any wires, right? Don't need to worry about it. We are always low potential because we are touching the ground. Okay, you can see we are always low potential because we're standing on the ground itself. Okay, next part over here. So what this means is regardless of what we touch, we're always at high, the electrical parts that we touch will always be at high potential. So you can treat us as we are zero. So something that's very, very high, like 240 watts, or 240 volts, it will definitely shock you, okay? The next heating effect, as I mentioned, wires can become very, very hot when you have very high current. So what happens is you can actually hot melted insulation. So it's not actually the wires that burn, it's actually the rubber or the plastic that wraps around it that burns, and you touch flammable materials, you start a fire itself. So just need to remember, it's very, very dangerous. Just high current, overheat the wires, start the electrical fire. So you don't need to go through in the details of how you start the electrical fire. You don't need to describe it in full details. All right. Now, so what causes the two above? It is damaged insulations or exposed wires. So some wires, if you keep using it for a long period of time, maybe the insulation is damaged. So if you damage it, you are exposing your bare wires. So what happens? If you touch it, some gundu, or you touch some metal parts that is touching the wires, which is just now what I said, the electrical fault, the problematic parts, right? You will have electric shock. Why? Because current flows through you. Okay, so remember, if current flows through a person, that is an electric shock. On the other hand, what about wet conditions? Water can conduct electricity, okay? So if you touch any appliance with your wet hands, you get electric shock. So you'll notice that most of the time in your bathrooms or in your shower itself, you'll notice that there's no switch inside. The switch is typically outside the door. So because why? If just now your hands are wet, you touch the switch, The switch there may have a small little gap, and if water drips in, you might get shocked. Okay, and what's so scary about getting electric shock is that you can't move away, because you are thinking like, oh, I get a shock, I just move my hand away straight away, right? But the problem is when you are shocked, your muscles will become paralyzed. You will get stuck there. So you are constantly getting shocked and you cannot escape. So it's very, very painful. And if no one comes and save you, you are basically standing there getting shocked for a long time. So it's very, very dangerous. You will die. Right? Number two, overloading itself. Basically, if you use the same power socket with many, many appliances, typically, how do we use this is we'll use a multi-plug. So multi-plugs actually help us connect more devices to the same socket, right? But don't forget, multi-plugs are parallel. So basically, they create parallel, and parallel, what happens? Your total current is I1 plus I2 plus so on and so forth, which means if you have many, many devices, very high current. And if you have very, very high current, what happens? If you have super duper high current itself, is that multiple appliance, high current causes heat up, causes electrical fire itself. Last but not least, we don't really use short circuit to explain. Short circuit is more of the what happens. It's more of this one causes short circuit, this one causes short circuit. Okay, so rather than short circuit directly being a direct cause, it's more of the intermediate effect. So if you can use the first three, this one we don't really use it as explanation. Okay, but if you did want to know more about your short circuit itself, you just need to remember I is V over R. So what happens is R is almost zero. Because we know that we always say, oh, short circuit, you must use a path with zero resistance, right? But in real life, you don't really have zero resistance. It will be like almost 0 ohms. So if it's almost zero itself, I will become infinite, very, very large. So you have an extremely large current. What happens is that you will definitely heat up and cause a fire. Short circuit, large current, heat up, cause fire, same thing. So all of this you can read on your own. Basically, just be careful with electricity. Don't be a gundu and go and touch it. Okay. Then next is your safety features. Because you notice that all of your electricity is so dangerous, right? So what can we do to protect ourselves? Now, we always connect all your safety features. Now, switch is not a safety feature. These are all your safety features. It is to add in to disconnect appliance from live wire, prevent electric shock and fire. Okay, so basically you want to always disconnect from your live wire itself. Now, why is that so? Your live wire is actually the most dangerous one. So the thing is, for example, if something went wrong with my setup, okay, so something went wrong. So normally I will put, for example, a switch. Now, if I open the switch here, current can no longer flow, right? This is your line, this is your neutral. So current cannot flow, you are disconnected. So this is good. Everyone is safe, right? So if there is a problem, nothing will happen to you. Because, for example, if there is no device, okay, there's no device, there's no earth wire, this is live, this is neutral. So if somebody hand itchy, go and touch this, what happens is current, if this is spoiled, it will flow through the person. This person will get zapped, they die. Okay, but if you have a live wire, even if you touch it, you won't be affected because your switch is open, current cannot flow through. So third scenario is what happens if I don't connect it at the live wire, I connect it at the neutral wire. I also open the switch one, right? Should be perfectly fine, right? Right? No. Answer is no, you will die. Why? Because current can flow through here, and if you touch it, current can flow through you, you will die. So the thing is, we always put your safety features and your switch at the live wire because you want to disconnect it straight away. So you can see the three scenarios. If you don't have the switch, you will die. If you have the switch, no current flow through at the live wire. But if you put it at the neutral wire, you connect it wrongly, or your 3-pin plug, you connect it wrongly, what happens is you die. So very important thing is, how do you know which wire should be the live wire? It will always be connected to your safety features and your switch. Everything must be at the live wire. So you can just imagine a neutral wire doesn't care. It's very neutral. It's very cool, very chill, right? So it doesn't actually contain anything. Neutral doesn't contain anything. Live wire is the most dangerous one. So we put all your safety features there. The earth wire is just connected to your light bulb. So these three scenarios on top is assuming that there's no earth wire. So a 2-pin plug, basically. Okay, so that is why in Singapore, we typically all use 3-pin plugs because we all can't see, we all scared to die. So most devices in Singapore all uses 3-pin plugs. It's very, very rare to see a 2-pin plug in Singapore. Okay, but for other countries, you see it more often. Now, next part over here, we want to talk about what is a fuse. A fuse basically is a safety feature. You want to use a fuse rating that's slightly higher than the current flowing through. Okay, so the thing is, what happens is this. How does it work? Current flows through, it melts, disconnect it, then you prevent electrical fire. Because what does a fuse do? It actually prevents high current. Okay, you can see over here, it prevents high current. So a fuse in real life, it looks just a capsule or container itself, and it will contain this very thin wire that is connected. So what happens when there's high current? It will melt. The wires inside will melt. Because the wires inside is actually a super duper thin wire itself. So when you have high enough current, it will melt. And when it melts, this is now open circuit. So open circuit, no more current. Okay, so how a fuse works is that basically once it melts, you have an open circuit, you basically don't have any more. So the thing is, your fuse rating that you have is basically the max current that it can accept. It should always be slightly higher. So your fuse rating should be higher than normal current. Okay, typically it's just your next whole number. So for example, if normal current, let's say is 2.5. So what happens? Your fuse should therefore be 3 amperes. Because basically you just round it up to the next whole number itself. But sometimes if you see, like for example, the normal current is 2.9, 3 might be a bit too close. Maybe you want to use 3.5 or 4. Okay, so just be careful about this. Your fuse, basically, this page is what we want to focus on, is the purpose, the function of it. But for the fuse, you need to know this extra part as well. The bad thing about a fuse is that this is a one-time use only. Which means if your fuse melts, you have to buy a brand new device or you have to install your own fuse, which is very, very dangerous. So normally if your fuse just melts, you just buy a new instrument straight away. So for me, one of my massagers actually spoiled because I actually used the wrong charger for it. So what happens is there was so much current flowing through it, it actually blew up the fuse. So you hear, then it stopped working already. So no matter what I try to use, it doesn't work. Why? Because now your fuse is now empty. There's an open circuit. So no matter how much you try to use current to charge it or whatsoever, doesn't work because now it's a melted fuse. Okay. By the way, if you don't know what a fuse looks like, normally this is a resistor, right? A fuse is just with a line through it. This is a fuse. Okay, so fuse and resistors are different. Do take note about this. Okay, so if you need to draw it in your circuit, it will be like this. Maybe I'll just draw a basic circuit to show you. So now basically you want to put your fuse in front, your light bulb, like this. So you can see this is my live wire. This is my neutral wire. Why? Because I contain the fuse. So if you notice your 3-pin plug, just now earlier on, also contains a fuse like this with a rectangle and a line through it. So this thing here is your fuse. Inside here, there is this small little wire that's inside. Okay. Now, if we go down the list, we have what we call next a circuit breaker. So a circuit breaker is a bit special. It is actually the same function as your fuse. You can just imagine it as a better fuse. It's a better fuse. Okay? Why is it better? It's reusable. Now the problem is it's more expensive. Okay, now if you all ever had a blackout at home before, basically this is caused by your circuit breaker, because why do you even have blackouts is that your electricity for your whole house, so your circuit breaker is actually for the whole entire house or for the entire building itself. So when there's too much current flowing through, maybe because one of your device is spoiled or something like that, to protect all of you at home, your whole house, the circuit breaker will trip and you will cut off all the electricity going to your house. So all you need to do when you have a blackout is don't panic, ask your parents and go to the circuit breaker itself and you can just turn it on. It is basically a switch. Okay, you can just imagine as it's just a panel with a lot of switches. So there's one main switch for the whole house, and then depending on how many rooms you have at home, you have different switches. So each room will have one switch each, which controls the electricity in that room. So if you cut it off straight away, then you basically have no electricity for that room itself. Okay, so it is the same phrasing itself, just that instead of melting, you see over here on top, right? Instead of melting for a fuse, you say that it trips. Okay, so if you disconnect it, the same thing, it will prevent electrical fire. Okay, so please turn off your lights and fans when you leave your house or whatsoever, because there have been a case where a student has burned down a building, a classroom, because they forgot to turn off the fans. They turned off the lights, yes, but they forgot to turn off the fans. So please don't try this at school. But basically, your security guard itself, they always go through in the evening to just patrol around to check that everything is closed. So they will just turn it off so that it prevents something like that. Okay. Now, for earth wire itself, what does it do? Earth wire is always connected to metal case. Okay, so and it will always be at low potential itself. So how do you do that? Basically, it is this part. Okay, so you must have a path of 0 ohms. So what happens is it will flow through the person instead, flow through earth wire instead of the person. It will prevent an electric shock. So just remember, earth wire is kind of like mother nature. So what do mothers do? Mothers will tend to protect their children, right? So your earth wire will actually protect you by taking the electric shock themselves. So what happens is when you have all of this, what happens is this is a short circuit, right? Due to the earth wire. So this part, right, is more of an expansion just in case, because this up to this point is 2 marks. So you need, if you want the extra mark itself, so this is the additional. It is short circuit due to earth wire current is very large. Okay, so what happens is the fuse in 3-pin plug will melt to disconnect appliance from live wire, preventing electric shocks as well. So just now on top, we already, electrical fire. Okay, because don't forget, when you have a short circuit, current is super duper large, right? So if you keep having super large current, you actually end up causing electrical fire, right? So to further protect you, that's why your 3-pin plug contains a fuse, because the fuse itself will actually prevent that high current from causing any damage to your house by melting the 3-pin plug in that, the fuse in the 3-pin plug. Okay, so do take note, for earth wire, you need to be a little bit more careful, because there were some cases where the schools did only gave 1 mark for the one on top. They actually wanted the whole entire explanation. So it's the green part plus the one below that will only score you 2 marks for some schools. So you just need to be very, very careful, check your school notes properly and double check. Okay.